Welcome. In this video, we're going to talk about how to analyze data from a questionnaire. I'm going to use as an example one questionnaire and data collected from it prepared by one of our students, Richard Kirkby, who was so nice to give us permission to use his work. Anyway, this is the questionnaire. He prepared in Excel with the questions in a drop-down menus, which is very nicely done. You basically click on any of the questions and you fill in if you are single, married, and so on and so on. The questionnaire deals with how people pay for things and how companies pay for things, and it kind of comes from his background, and he basically chose this topic because he works for a company issuing a new currency. So he basically wanted to know if there is any trend in people using less cash and more non-cash payments methods than before. He prepared it, as I said, he prepared it in Excel. He wrote this nice little introduction at the beginning, which is concise, only a few lines, nothing too much for any of the respondents to read. And then he had the respondents to answer about 22 questions, out of which first 12 are questions about the respondents: which country do they live, what gender they are, what age they are, marital status, number of dependents, and so on and so on and so on. And we call these questions control questions. And then the remaining questions, 13 to 22, are questions about the topic of his research. So he basically asked them how often they withdraw cash, which methods of payments they use, so debit cards, credit cards, coins, banknotes, prepaid cards, even cryptocurrencies, digital wallets, Apple Pay, and so on and so on. And then more questions on the topic, including question 20, which we're going to use in our analysis: estimated percentage of in-person purchases and transactions paid in cash. He prepared in Excel, which is it's a good way to do it, because you basically send it to your respondents, and they either they have to download the file, fill it in, save it somewhere, send to. Even better way to do it is if you use some of the platforms, online platforms like SurveyMonkey. In that case, people don't have to save any file, send you the file back. They basically just open a web page and fill it in, and press a button which says submit, and it's all done. This is pretty well done. It's not really so bothersome. It's basically one page which people just have to click around and send it to Richard over here. And now we'll get to the body of this research, which it's called the raw data. It's basically all data collected. So for each question, 0, 1, 2, 3, 4, and so on and so on, you have responses, and then he collected answers from 122 respondents, which is a really good sample. You should always aim for at least 100. 122 is good, but as I'll show you in the next few minutes, it's still not ideal, because if you wanted to stratify the sample, then you have to delete some data. You can also see that not all people actually filled all the fields. So for example, for the occupation, some people just didn't fill into the field, and in that case, if you then want to use that variable, that question as a variable in an analysis, you just have to delete the empty fields. So it's not ideal, but it's pretty good. Basically, an analysis is worth anything if you have at least 30 responses. You should always aim for at least 100. Richard did 122, which is pretty good. So it's definitely useful. It's definitely something which you can find some interesting relationships. So, one last thing, Richard also prepared these charts, which are really nicely prepared, as you can see. but they are really descriptive, and that's what most of the students do. They basically just prepare for like a chart for each question, and how the questions how the respondents kind of like were distributed along their responses, which is all right, especially if you do it as nicely as Richard, but it's not enough for a good dissertation. It's definitely not good enough for a distinction, because you also want to find out if the questions if the questions somehow relate to each other. So for example, if the gender, and the cashews number question, question number 20, if it corresponds with each other, and we don't really see it from such an analysis. And if he actually like created two plots for each gender, it doesn't really like show us much, because we don't know the significance of it, and we will have to run some tests, which he at the end did, but in these charts they are not there yet. So this is fine, but if you want a distinction, you really want to include some statistically significant relationships between the responses. So, and it's exactly what we're going to do. So let's get to it. With raw data, it's always a good idea to just leave the raw data as it is, because if you start making changes in this sheet, in the future you want to return to it, and you don't really know what you changed and what you didn't. You can also make mistakes if you copy, if you insert columns, if you move the data around, then you can. It's really easy to make a mistake, especially if you have empty columns over here. Then you sort the table, and suddenly everything, then like only part of the table actually sorts, and basically it can seriously influence the how many mistakes the original raw data includes. So we should always leave it unchanged. Instead, we'll do analysis in a different chart over here, which we'll call analysis. All right, and now I'm going to copy some of the columns which I want to use for my analysis. So always you copy the number, the number of the respondent. It's mostly for checking that you didn't make any mistake anywhere. Then I'm going to use gender and age, and then I'm going to go to the raw data. I want to go to the question number 20. How much of all of the payments the person makes consist of cash. So we can see that this person reported 20% cash use, 10%, this one 70, this one 100. So I'll copy that over here. One last thing which I probably want to do, actually, I'm going to do it once more. You saw that if I copied it in there, it kind of keeps the drop-down menu, and it might be a problematic in the future analysis, in the analysis I'm going to do. So I'm going to do it once more, and I'm going to copy it as data only. So it might look a little bit more confusing, but it doesn't matter because it's not really so complicated. So female and age, always press right button and then press this value button over here, and just copies everything unformatted. Basically, it just keeps just the data, no formatting, no edit functions. And question number 20. You always click on the header of the column. It just highlights the whole of the column from the beginning till the eternity. So it's exactly what we want. And this is, and again, I didn't press the values. So here we go. And now you can see, so this is our data set which we're going to use. I'm going to find out if the percentage of cashews somehow correspond with the age of the respondent and his or her gender. So first column, this variable, it's clearly categorical, so we'll have to use dummy variable no matter what. And which, if you remember from some of the previous modules, how to use the dummy variables, you basically replace them with months and zeros. So we'll use 1 for female and 0 for male, and basically we'll compare and we'll calculate the slope of the influence if being a female influences somehow the use of cash or not. And then we'll find a relationship also with age. Which is a little bit complicated because you can see that, even though it's a numerical data, it's in scales. It always goes from like some year to another year. So this person was 36 in to 65 category, but like some of the categories are much smaller. So what we could do is basically find a middle number, but there's going to be a huge mistake in that because well, this is 30 years, while this category is only 13 years, and there's even one category which is only 4 years, which is 17 to 22, which is, like the categories widths are not ideal. If you ask your respondents for age, just ask them for exact age with years, because then you can use it as a variable without any dummy variables or any scaling or anything else. And the analysis becomes much more precise, but also much more much easier. In this case, what we're going to do, we'll basically find a dummy variable for each of these categories, and it's going to take a little bit longer, but hopefully it will show up something interesting. So first of all, we'll create a dummy variable for gender. So I'm going to include female over here, and this first variable, which is going to be our dependent variable y, we'll call cash use. So female, and then for the age, we're going to have a few dummies, because there's a few categories, because the drop-down menus over here, they have to be defined somehow. So Richard has it really nicely organized here in the drop-downs sheet, and it's this this question, basically these are the scales which Richard used. So we want to use all of the dummies except one, because if you create dummy variables for like a few options, you always have to create as many dummies as there is categories -1, always -1, and it's because the the last option will be always swallowed by the intercept. It's because multicollinearity issue in a regression. You don't have to worry about it. Just remember that you have to always use as many variables as there is categories -1. So in this case, we have to drop one of these, either people under 16 or people over 65. Well, if we want to find out something interesting, which I'm a little bit worried that we probably want to eliminate the category which will be most extreme, which I think will be the -16 or people 16 and under, because, well, they probably use quite a lot of cash, because that's what people get from their parents. So I'm going to use only these variables and go to analysis, and you press a right button, press space special and transpose and OK, and it just copied all the categories over here. And now we'll have to build we basically want to now populate this whole area with ones and zeros. So for female, for the gender variable, I'm going to use, in all of the dummy variables, we're going to use if functions. So if if you write equal sign and if, it already offers you these options. We could also use ifs, but that's for more than one condition. We are okay with just one. So logical test v1 ask if this column, if this cell equals this cell, and the value, if it's true, 1, if it's not true, 0. Close parenthesis. And indeed, because male is not the same as female, it shows 0. If I copy it down, of course, I would have to log one of the so if just I'll show you that if I'm going to lock it, you lock this cell. You have to be really careful about highlighting just the the cell number, not with the comma, because then it shows error, which is what just happened. And you can press F4. These dollar signs appear over here, which means that wherever you copy it, it will stay the same. It will not move. If it's not locked, it always moves. So, and if I copy it down, indeed it says 1 because female is the same as female, and also if I double click on it, I can see which cells it compares, which is exactly the ones I want. But I'm going to delete it now. I'm also going to get rid of the dollar sign. You can delete them manually, but you can also keep pressing F4, and just if you press it 3 times, it removes them completely. And I'm going to copy the cell over here, and you can see that because they were not locked, they moved. So now I'm comparing age with age. It's 0 because 36 is not equal to 17. But now I actually need to lock it if I want to copy it on. So I need to lock this cell over here, which is this C4. So again, F4, the dollar sign appeared, and now I can just copy it. You always copy simply if you don't want to do any special copying as I did before with the transposing and copying all the values. You basically just press Ctrl C and Ctrl V. Here we go. So, and indeed, because this category over here is that the person was in the in the age category 36 to 65. Here the one appears over here, which is really cool. Now I want to copy it down, but again, I want to basically I don't want this part of the equation to change. So what I want to do is to press F4. And oh, sorry, that's the other one. So I'm just going to fix it. The E3, I don't want to be changed. Here I have to get rid of the dollar signs which we used before and lock the other one. Just pressing F4 repeatedly. And you have to do it for all of the cells. And the last one. Again, you have to be careful not to highlight the comma. And we are done. So, and now I can basically copy it down. To do it really quickly, especially with like large data sets, you can just click to the column 1 left, press Ctrl Shift down arrow. It will put me all the way down. Click 1 to the right, Ctrl Shift up arrow. And now I'll just press Ctrl V, and we populated this whole sheet with ones and zeros. If you want to make sure that it didn't really make any mistake anywhere, I'm just going to do a really quick check. So you write the function sum, and for all of these categories, there always have to be only one number 1 in there, except for the category which is which is only for people, only for respondents which were under 16 years and under. So I'm going to sum it up and press enter. And again, I'm going to copy it down pressing Control C, then going Control Shift down arrow, pressing one cell to the right, Control Shift up arrow, and voila. And now it shows me ones absolutely everywhere except for the people minus 16. And I can just check. So for all of these, yeah, minus 16, there's zeros over here, minus 16. It worked beautifully, so we know that our, data is now nicely populated. And now we can finally run the regression. So the cache use is going to be our y, and the variables, these variables will be our x's. So our dependent variable and our independent variable. To run the regression for like multiple linear regression we're going to use, you want to have the data analysis toolpack add in your Excel, and if you don't have it already, so you have to press File, Options, Add-ins. Check that you have Excel add-ins over here. You press Go and click it in. I already have it clicked in, so I don't have to do anything. So I'm just going to press OK. And then if you go to your data, there's a data analysis option button over here, which you're going to use. And from all of these options, we're going to choose regression. And Y is our cache use. I'm going to again just click on the first cell and press Control Shift down arrow. That highlights it all. And the X, I want to highlight all of the variables which I have available. So all of these, and again press Control Shift down arrow. And then because I highlighted labels, I want to use the labels. If you don't do it, it will think that the first number, the first highlighted cell is also a number, and because it's a label, it will throw out an error because it will not recognize it. Then the confidence interval, well, I'm going to be optimistic and put 99 in there. Basically, that's really high certainty. And then output range, where do I want the regression table to appear? I'm going to click K3. So and now all you have to do is to press OK. And here is our regression. If you highlight these columns over here and press between them twice, just left click on both, like in between the columns, it will extend the columns, so all of these numbers nicely fit in there. So first of all, R square of our regression is 0.41, which, if you remember how R square is defined, R square is a ratio between explained error and total error, which basically, very easy way how to think about it is, it's a percentage. So 41% of how much people use cache is determined by gender and age, which is actually a really high percentage, and is definitely presentable in your presentation, because if you can explain 41% of behavior of how much cache people use by only two factors, only gender and age, that's really cool. So, and that's exactly your conclusion of this regression. And then we're going to look at all the factors themselves. So gender is over here, and these are slopes. They call them coefficients, but we know it's basically in the regression, it's a slope. So females use 7% less cache, or almost 8% less cache than males. Basically, to interpret it always, because male is included in the being a male is included in the intercept, you always compare this number against the the other missing dummy variable. So in this case, females because it's a minus, and our variable for cash use was how much cash they use. They use 7% less cash than males. And then for age, you can again see that all of the slopes are very, very negative. And it's again because we compare all of these numbers against that one missing variable, which is again included in the intercept, and that was for all the people who were under who were 16 or under. And obviously, because people under 16, they use the cash most, our prediction was correct. You can see how much less cash they use compared to being 16 and under. So this category 16 to 21 use 31% less cash. This category 22 and to 35, 60%, and goes on 59 and 41% less. So even people over 65 use much less cash than under 16. They can use like all the other kinds of payments like bank transfers, but also credit cards and so on. And then we'll get to the p-values and confidence intervals. And confidence intervals are usually a little bit easier to explain. Basically, what you need to know is that the slope or the effect of being a female or being a certain age group is always statistically significant if between the lower and upper limit it doesn't go over 0. So, for example, for female, it actually does go over 0, even at 95% certainty. It also, of course, goes over 0 for 99% of certainty. But I can also look at the p-value over here, and it's 0.06, which, or 0.068. So it can be basically, almost rounded to 0.07. So what is the certainty which I actually know that this relationship actually exists, if that female use less cash than males? It's always 1 minus this number, and in percentages. So if I just write 1 minus this number, and now I'm just going to change it to percentages. So this is the certainty. It's 93.12. So even though it didn't show up as significant at 95 or 99, I know it's going to be significant at 90%. So if you have such a low or slightly higher p-value, you can calculate the certainty really quickly, and then you can basically just say, okay, there's only 6.82 percent chance of a false positive, and 93% it's pretty good certainty, especially if we are talking about sample data. And for all the other slopes, so it doesn't go over 0 anywhere, so they seem to be all significant. We'll look at the p-values. These are really small numbers. This one will, for people 17 to 21, it's a category which is really close to being under 16, so it's not significant. It is significant in 95, but it's not. It's significant in 95, but it's not significant in 99. You can again see that these limits go over 0. So we can be 99% sure, but we can be 95% sure. And again, we can do the same calculation as over here, and because this is 0.03, we are roughly 97% certain that this relationship exists, and there is 3% chance of a false positive. And these, you can see that these numbers basically, if you don't know how to read these numbers, with a dash and 10, it basically moves the decimal point by 10 points. So these are pretty damn close to 0. as well as this one is. Again, here even at 99% certainly we know that this relationship between being over 95 years and the cashews exists. And that's how you interpret it in your dissertation, and you can insert basically this whole table in there and show that all of these relationships exist. So thank you very much for listening. I hope it was somehow helpful. If you have any questions, just contact me throughout Canvas. And I wish you all the good luck for the dissertation. See you next video.